Today, we're diving into a huge conflict happening right at the heart of technology. It's this clash between making AI smarter and, keeping our personal data private. And it's a battle that really does affect every single one of us. So, here's the big question, the one we're going to tackle. Can an AI actually learn from our data without learning all of our secrets? For years, this has been a super tough nut to crack for researchers, but a new solution might have just done it. Let's see how. Okay, first things first. Let's really break down the problem itself, the AI privacy dilemma. This is the absolute core of what we're trying to solve here. You see, at the heart of all this powerful AI are things called graph neural networks, or GNNs. They are brilliant at understanding connections, in our social circles, in biology, even in financial transactions. And because they can analyze all these relationships, they can make some scarily accurate predictions. The secret sauce here is a principle called homophily. Now, that's a fancy word, but the idea behind it is super simple. Birds of a feather flock together. AI uses the fact that similar people, or nodes in a network, tend to connect. It basically uses your friends to figure you out. And this brings us to the big trade-off, the fundamental problem. On one side, if we just feed the AI all our data, we get amazing performance, but we also get huge privacy risks. On the other side, if we limit the data to protect ourselves, the AI just doesn't work that well. It's a classic catch-22, right? Now, of course, this isn't a brand new problem. People have tried to solve it before. So let's take a quick look at one of those early ideas to see why it didn't quite work out. One of the first really clever solutions was a technique called feature propagation, or FP. The whole idea was to help AI work with incomplete data, which is exactly what happens when we try to protect our privacy by holding some information back. The logic is pretty simple, actually. If the AI is missing some info about you, it just looks at your friends or connections, your neighbors in the network, and it uses their info to make a really good guess about you. It literally propagates features across the network to fill in those blanks. But yeah, there was a huge problem. FT had two massive flaws. First, its performance was just okay, nowhere near as good as an AI using the full data set. And second, and this is the ironic part, it could still leak your secrets by basically reconstructing your private data. So it kind of defeated the whole purpose. Which leads us to the million-dollar question. How can we get all the benefits of sharing information to make AI better without putting our privacy on the line? And this right here is where a totally new, groundbreaking framework comes into play. It's a multi-view solution that looks at this whole problem in a completely different way. The main idea is just so elegant and simple. Instead of giving the AI one single, perfectly clear and risky picture of our data, this new approach creates lots and lots of blurry ones. By themselves, they don't reveal much, but when you put them all together, you get a rich, insightful picture. The technique is called multi-view feature propagation, or MFP. What it does is create a bunch of these partial and intentionally noisy views of the data. Each one is processed on its own, and only then are they all combined at the very end. So here's how it actually works. For each view, the system grabs a tiny, random piece of your information. Then, and this is the key, it replaces everything else with just random noise. That's what makes the picture blurry. Then, each of these messy, incomplete views gets sent through the network. Finally, all the results are combined to create a super useful data representation for the AI that is, by its very design, private. So, the theory sounds amazing, right? But how does it actually hold up in the real world? Let's get into the results. Okay, what's just mind-blowing here are the test conditions. This is the AI's accuracy after, get this, a staggering 99% of the original data was thrown out for privacy. And as you can see, the new multi-view method, MFP, that tall bar on the right, it just crushes all the older approaches. On a key dataset called Cora, MFP had an accuracy of 80.1%. Now, this isn't just a small step up. This is a whole new level of performance, especially under such extreme privacy constraints. It's a real game changer. And that brings us to the other half of the story, privacy. This chart shows how much of the original sensitive data can be figured out from the final result. With the old FP method, you can see there's a pretty clear connection back to the original data. But with our new MFP method, the connection is practically gone. It's basically indistinguishable from random noise.
So, the verdict is in. This multi-view approach doesn't just nudge the needle, it completely breaks that old trade-off. It manages to be more accurate with its predictions while being way, way more private.
All right, so we've got a new AI framework that's better and safer, but what does this actually mean for you and me in our daily lives? Let's talk about the real-world impact.
This kind of tech could completely change the services we use every single day. I mean, imagine getting better recommendations on social media or shopping sites, but without them needing to track your every move. Or think about banks catching fraud more effectively, or researchers analyzing health data to find cures, all while protecting our individual privacy. The biggest takeaway here is really a message of hope. For so long, it's felt like we had to make a choice. Do we want smart tech, or do we want our privacy? This research shows that with some really clever thinking, we might actually get to have both. And that leaves us with a really fascinating question to chew on. If we can solve the privacy versus utility dilemma, what other impossible problems could be next? As AI keeps getting better, maybe the biggest breakthroughs won't be just about what it can do, but about how it does it responsibly.